Okay. Welcome to this um section. All right. So today we are going to take, or today we are taking our program a little step further. So we are going to look at networking today. All right. Um. So we'll try to be as detailed as possible, as possible. And if you have any question, I may not see you when you raise your hands. So just you can stop me anywhere and ask your question. So, but keep an open mind because it's going to be a very long journey. So I'll start by saying that if you don't understand networking, especially in the cloud, now AWS is definitely going to confuse you, not just AWS, even if you are working with other cloud platforms, because you end up creating resources. And these resources will definitely need to talk to each other. And even if you are using the default network, when this application breaks, it becomes very, very difficult for you to fix them. All right. So, what is a network? So, you can see a network as a system where devices communicate with each other. So, devices communicate. All right. But they communicate using an address. Okay. They communicate using a structured data. And of course, there are also things like routing decision. We are going to come to this. So now, what I refer to devices are things like your servers, your laptops, your phones, all right, your smart TVs. So these are devices. But for the purpose of this class, we are going to limit ourselves to servers, but the whole application applies to all these guys. All right. So we limit ourselves to servers because most of the time we are basically configuring servers. Now, there are three things that must always exist whenever we talk about networks. So the first thing is addressing. What does addressing do? You definitely know what you definitely want to know who you are talking to. So addressing simply um, helps you identify who you are talking to. So now in networks, all right. So each devices on the internet presently has an IP address. All right. So an IP address is just like your home address. For you to identify a particular house in a particular street, that house must have an address. So the same thing is applicable to networks or devices on the internet. All right. So each of your devices has a unique IP address, all right, or a unique address attached to it. Now, the second thing you will likely see is a service, identification of service. Now, a service actually answers another question, which is how do I get there? Addressing answers who you are talking to. Identification of service answers how does a particular data get to its destination. Now we have so many types of services, and we've actually used one. In fact, we have been using so many services without us knowing. Now, recently, we have used SSH. We've used SSH. What does SSH do? Um, SSH allows us to securely access a remote device, just like what we saw with EC2. We also have HTTP. HTTP. Now, HTTP is how devices communicate on the web. For instance, the website. We have HTTPS, which is the secured version of HTTP. HTTPS. We have hundreds of services. We have SFTP and the rest of those guys. So, identification of a service helps us to determine how a particular data gets to its destination. For instance, let's assume you want to send, let's say, you want to send images or pictures to another server. First, you need the IP address of the server you want to send that image to. Now, you need to understand, the second thing you need to know is what kind of service supports images. Imagine you trying to, because you might get the IP address right, but imagine you trying to use the SSH service to send your images. The other server may not be able to receive that data. All right. So you need to get the service right. Now, another thing you'd also look at is path determination. Sorry, I mixed this up. So path determination determines how a particular data gets there. That is, how do I get there? All right. But your service determines what you're actually talking to. So in essence, if any of these guys is missing, then your communication fails. So you get the IP address, you identify the type of service you want to use for your communication, and you determine how to get there. So this is how network actually works. Now let us go a little bit further. Let us see how communication actually happens. For instance, let us use google.com. Let's say you are trying to visit google.com. What happens? You insert google.com on the browser, all right? Now, the very first thing that happens is DNS resolution. Now, what happens here? The server asks DNS, or the system asks DNS to give you the IP address of google.com, because the whole essence of google.com is for accessibility and also to remember at a particular time. All right. So because imagine you having to remember all the website IP address or all the server's IP address. For instance, I have a website. how do you reach that website? You need a DNS of that website. But before DNS, because DNS actually came to solve the issue of trying to remember servers' IP addresses. So with DNS, you get to map the IP address to a particular DNS, and when you type that particular DNS on your browser, then DNS resolutes that particular DNS name to an IP address. So the first thing is DNS resolution. Now, the second thing is more of packet construction. So a typical, this is, for instance, DNS resolution is going to resolve this. For instance, I'm just going to use just an example IP, maybe 184. Let me just use anything, .34. So for most of us that are new to IP address, so IP address is just like a home address for all the networks, or sorry, for all the device in a particular network. So this is an identifier, all right? So this is going to resolute Google DNS name to this IP address. Then the next thing is packet construction. So the system is going to create a packet, all right, containing things like source IP, the source IP is your machine IP. Okay. Then is also going to max it with the destination IP where you are trying to access. Is also going to max it with a source port. Now, what is a port? We saw service. What is a port? So a port in a network is like a door on a device. Just liken it to a door on a device. So a port is numbered from 0 to 65535. So you can look at port as an apartment number. All right. So each service is bind to a particular port. For instance, SSH is bind to port 22. HTTP is bind to port 80. HTTPS is bind to port 443. All right. So for the packet construction, you're going to have the source IP, the machine IP, the source IP is your machine IP, all right, what you're using for that communication. Then the destination IP is going to have the source port, which is your own port, and the destination port. Okay, so it's also going to have a payload. So payload is more like the data you are trying to request. All right. So another thing, and another thing that actually happens, we've seen DNS resolution, we've seen packet construction. Another thing that also happens behind the hood is routing decision. So what happens in routing decision is the system is going to check if this IP is in a local network. If it is not in a local network, it is going to send it to a default gateway. Don't worry about most of these things. We are going to see them in practical. And then another thing that happens is packet. Hello?
Yes, we can see your screen. It kind of went off.
Okay, thank you. So another thing that happened is packets um traversal, because packet moves around things like routers, like your home router, your ISPs, your carrier networks, and your internet backbone. All right. Then another thing that happens again, the last thing that happens is the destination processing. That is where the server you are trying to access, destination processing. So the server is going to check the port, is going to process the request, and is going to send the response back. So now, so now, these are literally what happens. All these steps are literally what happens when you try to visit a particular website, say google.com. The first thing is your DNS resolution, packet construction, routing decision, packet traversal, then the destination processing. So again, as DevOps engineer, it is really not our duty to design networks. It is not our duty. It is not our duty to design networks. All right. So, but we still need to have it at the back of our mind what actually happens behind the hood. Please give me a minute. All right, thank you. So now let us look at what a typical IP address looks like. So a typical IP address looks like let's say 192.168 dot 1 dot 10. All right. So this is what a typical IP address looks like. Okay. So now each of these guys, there's what we call octets. Now I just want us to just have an idea about how most of these things, all right? So not like we are network engineers, okay? But at least you should know what happens behind the hood. So now each of these guys, each of these segments are referred to as octets. So there are 4 octets here. One, I'm sure we know about our binary numbers, all right? So each of these guys are what? 8 bits. Each of these guys are 8 bits. So a typical IP version 4 address has 32 bits. All right. So there are 4 octets. Each octet has 8 bits. That is 0 and 1, combination of 0 and 1s, and total of 32 bits. So 8 times 4 is going to make it 32. So total of 32 bits. Now, why I'm bringing this up is that your system, because this is in decimal, so your server or your laptop, your machine, any machine you use is going to translate this into bits. Okay, so in essence, this is converted to base 2. This is converted to base 2, converted to base 2, converted to base 2. Again, you don't have to know this, all right? So, but I don't want to jump into AWS networking without considering what actually happens behind the hood. So then we've talked about ports and services. So a service is a process that binds to a port. Now, each communication that happens on your laptop, on a server, are known as processes. And each of these processes bind to a port. For instance, let me use my laptop as an instance. Now, if you want to have access to my laptop, then my operating system is Linux, all right? So if you want a remote access, that means you must access it through SSH. Now, SSH is accessed on port 22. If I should deny access to port 22 on my network, that means even if you have the right credentials, because that process is actually blocked, you will not have access. That's literally what happens. All right. So everything running on a server is a process, and each of those processes are bind to a particular port. So that means full communication always looks like this. Full communication, let us assume that we are visiting Google and Google's IP address is 94.34.42 or .1, 82.1. Now the full communication is always the IP address and the ports. So full communication always looks like this. If you are visiting Google on HTTPS, the full communication looks like this, 443. Now, if you are trying to access my laptop, let's assume my laptop's IP is 96.4.4.9.8. So the full communication looks like this, because this is a port and this port is bind to what? SSH, and this is my IP address. So in essence, one machine can run multiple services using different ports. This is one machine. This same machine can run SSH. This same machine can run HTTP. It can run SFTP. It can run basically anything. All right. But the thing is that one port cannot run two services. If not, there's going to be a port conflict. If not, there's going to be a port conflict. Now, networking is very important in AWS because AWS gives us compute. For instance, EC2, we've used EC2. AWS gives us compute. All right? But without networks, your compute is as useless as possible. So this is why network is very important. So networking makes these resources usable. So without networking, EC2 cannot be accessed. That is why when you create an EC2 instance and you use the default VPC, you can access that EC2 using SSH. Without network, you will not be able to access it. Without network, services cannot communicate. Let's assume you want to use that server to host a website. Then that will not be possible. All right. So AWS is more like a network system first, then compute is second. So for every resource you create in AWS, networking always comes first, especially compute resources. So in AWS, there is a service that is very much in charge of networking, and that service is known as VPC. VPC. VPC means Virtual Private Cloud. So a VPC is just a logical isolated network inside AWS. All right. So when you create this network, then you can use it to host your infrastructures. All right. So it is isolated. Your traffic is separated. Your IP range, we are going to look at IP range. Your IP range is controlled by you. Nobody is allowed to, or nobody is allowed inside your VPC unless you grant access. So we've been using the default VPC all this while, but for a production environment, we don't use the default VPC because it has a very flat structure. It is poorly segmented and it is not scalable. The default VPC is not scalable. So henceforth, we'll create our own VPC unless maybe for demonstration purpose, all right, for any infrastructure we want to host in AWS. Now, when creating a VPC in AWS, there are several things we need to consider. The very first one is known as CIDR. What is CIDR? Remember you heard me mention IP range. IP range. So CIDR simply means classless inter-domain routing. This is the full meaning of CIDR. All right. So CIDR is nothing more than a way to allocate IP addresses. All right. It's just a way to allocate IP addresses. All right. So there's a very big mystery behind CIDR. All right. CIDR. So CIDR is classless. Before CIDR, we had something we call classful. So before then, or before now, IP addresses were always segmented into classes. We had the class A IP addresses. We have the class B up to class, I think class E. All right. So this is the old way of networking. All right. So classless replace this guy. All right. So what you'll be seeing in production is CIDR, which is a classless inter-domain routing. So CIDR actually defines how many bits represent the network versus host. Now, in a particular network or in a particular IP addresses, an IP addresses is divided into two main parts. The network part, and we have the host part. All right, we have the host part. For instance, if we say, let's say you want to design a network for your infrastructure, first of all, the first thing you do is what? You need to determine your IP address range. All right, so you can say, okay, I'm going to pick 10.0.0.0/16. So the whole of this now becomes your CIDR. So let us break this down. The total IP address is what? Like we said, 32 bits. So /16 means we keep the 16 bits for network, all right, and 16 bits for host. Again, just follow me, all right? You don't really need to, even if, well, just try to understand it, okay? For most of us, this is like the first time we are seeing something like this, all right? So it should not be discouraging, okay? But when we get to the practical aspect, all of these things will not matter, because at the end of the day, when, let's say, your CTO in a particular organization you'll be working for, what happens is that the guy is going to give you the CIDR, all right, for you to use to configure the network. It is not your responsibility to determine the CIDR. Yours is just to configure the network. But I don't just want to jump into configuring the network, but at least even if we are talking on the surface, let us just see what actually happens. All right. So understand that a particular IP address, when you see an IP address is divided into two, the network aspect and the host. What does host means? Hosts are things like your laptop, your servers, your fridge, your smart fridge, your smart TV. Those are hosts. All right. Your printers, those are examples of hosts. So let us break this down. We saw that a typical IP address has what? 32 bits. All right, so 16 bits for network, 16 bits for host. If tomorrow you see a CIDR like 10.0.0.0/24, all right, so what should come to your mind is 24 bits for what? Network. All right, then the remaining bits is used for host. Okay, so now let us work with this. So in binary, if you convert 10 to binary, I think you are going to have 1, 1, 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So for most of us that are actually confused, if you should count the whole of this, you are going to get 32. All right. So this is the equivalent for this guy. Now we say that 16 bits for network and 16 bits for host. All right. So what happens is that the first 16, which is 8 plus 8, is going to be for network. So this is going to change to 1, 2, 3, 4, 5, 6, 7, 8. All right. So this can be converted to 255.255.0.0. So someone here asked if this is equivalent to subnet max. Now let us go to my IP address. All right. So if I do if config, is it if config or IP? Yeah. If we do if config and I check, this is my router. No, it is this guy. This is where I'm connected to. This is my IP address, 192.168.1.29. So, and this is what? The subnet max. The subnet max is what? 255.255.255.0. So that means this is what? /24. Let us see how we arrived at /24. So 12/24 means the network bit is what? 24. All right. So we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And the rest is for host. 1, 2, 3, 4, 5, 6, 7, 8. All right. So this is literally what happens. Okay. So if you see a subnet max tomorrow, okay, so that means it was gotten from your CIDR. So this is really what I want us to note. So now we have segmented this for this, all right? Now, another thing you definitely mean, so okay, before we move forward, what actually means is that, or what this means is that the capacity of this network is always 2 raised to power where is the symbol? I think it's this one. 2 raised to power 16. All right, 2 raised to power 16, which is equivalent to how many IP addresses your network can carry. Now, 2 raised to power 16 is, I think, equivalent to 65,536. All right. Now, imagine you are in a network and you're using /16, which is your CIDR notation is what? /16. And what you have is 65,536 IPs. What happens? And your network only needs to take care of, let's say, 100 hosts. That means out of 65,000, you only need 100 IPs. That means the rest of these IPs are now a waste. It is very hard to control. All right. It is it now becomes a waste in your network. All right, and we don't want that. So even in your VPC, the first thing is what? Your CIDR. The next thing is what? The next thing you need to consider is your subnet. There's what we call subnet. What is subnet? Subnet is just like you dividing this your network into smaller chunks so that it will be very easy for you to manage. All right. So what actually happens in subnetting is, now notice that our host here, our network here is what? 16, and our host is 16. If we want to divide this network into subnets, so we are more like borrowing some ones, all right, from the host, from the network bit to the host, all right? So for instance, what actually happens is that we are now going from /16, instead of /16, we are going to /24. Again, just follow me, all right? So instead of having this guy, so what we now have is the host portion of this network is also going to turn to network, so that we are going to have smaller IPs. All right. So what we now have is what? 1, 2, 3, 4, 5, 6, 7, 8. So automatically this now becomes /24. All right. So you can now have different subnets. Now you can have your private subnet, you can have your public subnet, you can have different types of subnets. So it becomes very easy for you to manage. All right. So now this was our main CIDR. Okay. So instead of 10.0.0.0/16 in our subnet, what we now have is what? 10.0, but instead of .0, all right, instead of dot 0, we now have what? Dot 1.0/24. All right, so this becomes our very first subnet. You can have another subnet, 10.0.2.0/24. So this becomes another subnet. What does /24 means? It means that 24 bits is for what? Network, and 8 is for host. So that means each of our subnets now is going to have 2 raised to power 8 IPs. 2 raised to power 8 IPs. All right. So which is going to give us, I think 256. 256. So now can we see this is now smaller to manage. So we now have 256 IPs per subnet. Now, depending on the number of subnets you want, all right, you can, in a particular network, depending on the availability, you can have different number of subnets. So we can have .0, .3, .0/24. Okay, so that means this is what is going to change. This is now separate network. We are now managing each of these networks separately. So let's assume in this subnet, we have a host, or we launch an EC2 server inside this host. What happens? So that means our IP address can be 10.0.1.1. This is going to be our first IP address for a particular host. Remember that this is what is now changing. So the rest of these guys is now part of the network. So if you notice what happens, this is why we have this guy. So this is my gateway. All right. This is my gateway. And this is my IP address. All right. That is my host. All right. My TV is also connected to this gateway, so that my TV is going to have a different IP. It can have 130, it can have 150. All right. Some other things are also connected to this gateway. So it's literally as simple as this. Okay, because of this subnet mask. So this is how networks are segmented. So the first thing is what? The CIDR. The next thing is what? The subnets. Again, I know these calculations because I am also a network engineer, aside being a DevOps engineer. So if you're a DevOps engineer, you have no business with knowing how to calculate most of these things, unless maybe out of curiosity. So what you are going to be given, you'll be given a CIDR range, all right? Then you'll be given the number of subnets you should configure. So the next thing is what? Route table. So what is route table? A route table is what? Is going to define your traffic direction. So what route table do for you is it's going to give each of your hosts and the subnets a particular route to follow when they are communicating with each other. All right. So that is what a route table is going to do. Now, a route table is just like a map. All right. Forget the English. Route table is, you can liken it to a map. Okay. You can liken it to a particular road or a route. All right. If you are going from one street to another, there's always a route you follow. So that is a route table. All right. So let's assume I have an EC2 server here. I also have an EC2 server here. So the purpose of route table is to define the communication route that this particular EC2 is going to use to reach this other EC2. Now, aside route table, you're also going to configure, there's what we call internet gateway. Now, if you want resources in your subnet to reach the internet, let's assume you are hosting a website. You definitely need an internet gateway for people to be able to reach your each of those servers in your subnet. So we need an internet gateway. Okay. Then there's also what we call NAT gateway, network access translator. So now, since our job is to design security first architecture with the no trust security policy, we basically have two types of subnets. You always come across two types of subnets. All right. So we can have the public subnet. You can have the public subnet. All right. You can also have the private subnet. Now, because of zero trust, you would not want to configure your resources in the public subnet. So instead, you can impute most of your resources here, the private subnet. Resources like your database, please, should always go to the private subnet. Things that have sensitive information should always go to the private subnet. Things like maybe your web server can be in the private subnet. When we start considering things like load balancers, they can be in the public subnet. But your database, your back-end applications, your APIs, all right, can be in the private subnet because they should not be reachable from the internet. All right. So what they are going to use to communicate with each other is the private IPs. We're also going to look at that. Now, if you want this guy to talk to the internet, then you are going to bring what we call NAT gateway. So NAT only allows outbound traffic. Now we have two types of traffic. We have the outbound traffic and we also have the inbound traffic. Outbound is what is leaving your server. Inbound is what is coming into your server. All right. If you want this guy to make an API request, maybe a kind of outbound request, then you need to bring in a NAT gateway. So a NAT gateway is going to be, and a NAT gateway should always be in your public subnet. All right. So, but we are going to see the implementation of most of these stuffs. So another thing is your security groups. A security group is like your host firewalls. So security group controls what kind of request can come into your subnet or what kind of request can leave your subnet. Before we proceed to the practical implementation of this, is there any question?
Not over here.
Okay. Please, I'm literally expecting questions.
I think the question for me is more like the cedar blocks, but I don't think we have to worry about that, like you said, right? It's more like a administrative thing.
Yes, yes, yes. But if you want to clear your doubts, you can ask your question.
No, I don't really have doubts. It just sometimes it just get confusing. I mean, I understand what you're doing. I mean, I've been reading on that for a long time now, but sometimes the numbers just get astronomical. So
I understand. Okay.
Hi.
Hello.
Yeah. So you mentioned something about security groups. which I
Yeah.
know is a term used in AWS. And you mentioned something about the host firewall. It's like the host
Mm,
firewall. And from my understanding of host firewall, it's something that's installed on a device, right?
mm.
So, right? So like
Yes, yes.
installed on your device. So that means for this security group, that means it will be linked to your instance, EC2 instance, right?
Yes, yes.
Okay, so okay. I just wanted to confirm. Yeah.
Okay.
Go.
So while I actually said that it is linked to a particular subnet, is that now each of those subnets, you have resources in there. So any resource that is attached to that particular subnet can assume that security group. So, but it is at the host level, just like you're installing things like your maybe enabling firewall for your laptop. Let's say you don't want a particular traffic to come into your laptop. So aside security group, we also have what we call NACL. NACL. All right. So what NACL means is NACL stands for Network Access Control Lists. So NACL works at the VPC level. So let us look at something. Let us assume this is our VPC or our network. Then we have our subnet here. Okay. Then we also have another subnet here. So inside here, we have what? Security group. So I'm going to abbreviate it as SG. So each of these subnets has its own different SG, all right? But the NACL works at the network level. So this guy controls whatever traffic comes inside here, but NACL controls the traffic coming inside the VPC itself, all right? So NACL is stateless. All right, NACL is stateless. NACL is stateless. So so NACL is stateless. Why this guy is stateful. All right. So this guy is stateful. So what I mean by this is if you configure the inbound traffic in security group, sometimes you don't necessarily need to configure the outbound traffic because the inbound traffic is going to leave the way it came, all right? But it's not the same thing with NACL. Let's assume you say, okay, I want port 80 to come inside the VPC. You must explicitly state that port 80 should leave the VPC the way it came, all right? But in security group, don't really have to configure that. But sometimes configuring NACL is always very rare. But the thing you always need to configure is your security group. So to recap, NACL checks inbound traffic separately and outbound traffic separately, but security group does the opposite. All right. So now we are going to, I dropped something in the chat. So this is a typical design. All right. So this is a typical design for a VPC. Again, you don't really need to understand the calculations behind the CIDR at the subnet, but if you can just read up on it. Okay. So if you notice, so this is our project title. All right. So we are going to design and deploy a secure AWS VPC network and website. All right. So today we are also going to, what we are going to do today is we are going to design a VPC. All right. Then hosts an EC2 instance inside our VPC. After configuring our VPC, then host a very small website in that VPC. Sorry, in that EC2. So that's what we are going to do today. So we are going to implement security controls using security group. We are going to deploy a public-facing website inside the network. We are going to configure domain resolution for public access. So I hashtag this may not because most of us don't really know how domain works, but since it's our first class, I think I should consider that. So this project simulates how a real cloud deployment scenario is for a non-profit organization, so that needs an online presence. Okay, so these are the project objectives, and this is a website. So when we reach the website aspect, you just follow my lead, all right? Because we've not actually done version control, all right? But you just follow my lead. So if you notice, we have been given the CIDR. We are also given the public subnet and the private subnet. So, but we are asked to configure the internet gateway, configure the route table, then launch EC2 server. For the security design, this is a security design. Since this is a website, we need to do what? Allow port 80 on where? Our server. Since this is also a website must be secure. This is what I mean by secure. Whenever you see HTTPS on a website, that means a certificate is attached to that website. So if you go to a particular website, you always see a key-like button here. So what this means is that this website is secured. All right. So if you also check the full URL, you are going to see HTTPS. If you click on this key, you see connection is secured. All right. So this means this website is what is running on 443. So we are also going to allow 443, even if we are not going to configure that today. All right. Then for the SSH, we are going to only allow administrative access on SSH. What this means is that SSH should only be limited to you. No one, since you are the server administrator, no one should be able to have access to this SSH, even if they have the public key or even if they have the private key and your IP address. It is only limited to your own IP address. That is your host machine. So now this is what I love to do. Now, we are trying to combine cloud architecturing and DevOps. So this is what I like to do. What we are going to do is we are going to architect the whole thing first before we go to AWS to deploy. So the tool I love to use for my visual representation is known as draw.io. So if you hit enter, draw.io is going to load up, although they are now hosted on diagrams.net. But if you type draw.io, it's going to take you to diagrams.net. All right. So, sorry, let me open up a new blank diagram. Then I will just click on create. All right. So it's going to open up a blank canvas for you. So you can make your architectural patterns here and take a screenshot or save it, maybe make a post about it, maybe on LinkedIn, on any social media platform. Now, the first thing you actually look at is on your left panel, all right, you have these guys here, all right? So it is known as shapes, okay? So now, if you are opening up this guy for the first time, then you're actually going to have some minimal shapes. So what you do is you go to more shapes. When you go to more shapes, then scroll down, you're going to see AWS. So that means you can use this to architect for AWS, Azure, Cisco, and all those stuffs. All right. So if, for instance, if I untick these guys, I may not have access to my AWS tools again. So they are not here. All right. So what I'll do is I'll go to more shapes, then check for AWS. Now, just one is enough. But if you need, because these are actually different releases. All right. So I'm going to tick on each of these. So AWS 17, 18, and 2026. So what happens is that this guy has some of the AWS tools for 2026. Then 3D, and I'm going to apply. All right. So now, what are we trying to design? We're trying to design a VPC. So I'll come here, search for VPC. Okay. So I'll hit enter. All right. So this is what a VPC looks like. All right. So you can take any of these guys. So what I'll simply do is I can drag this. Okay. Now, what is our CIDR for our VPC? Our CIDR for VPC is what? 10.0.0/16. So I'm going to come here and click on the plus button and add a text. Okay. So I can just paste this here and kindly move this to here. So after VPC, what do we need? We need subnets. And how many subnets are we asked to create? We are asked to create 2 subnets, public subnet and private subnet. So I'll come here, search for subnet. So this is what a subnet looks like. So any of these guys can actually work. So I can come here. Sorry. Okay, so what I'm going to do is I'll simply take this guy to the back so that I can be able to click this. So this is what I'm going to do. I'll come to style, or is it arrange? I think arrange. So to back, so it's, yeah, to back. Why is this not working? Okay. Think I'll go with another one. So let me just go with this one to save time. All right, so I'll duplicate this, right click, duplicate. Then this is our 2 subnets. So I can label this public subnet. All right, so I can label this public. All right, then can also create another tag. Then for private. Now, the next thing I'll do is what? Route table. So I'm going to have 2 route table. Now, why we are having 2 route table is the private subnet is not meant to go to the internet. All right. Since the public subnet will be routed to the internet, we should have a separate route table for both of them. All right. So this is a route table. Okay, so can duplicate this for this particular guy. All right. Now, what again do we need? Internet gateway, IGW. Let me type in full internet gateway. So this is a gateway. All right. So now the gateway is going to be what? Outside the VIP, because this is what is going to bring network into external network into the VPC. All right. So that means it must pass through the what? The route table, the public subnet route table. All right. So what again? Now our EC2. So I'll search for EC2. So this is what EC2 looks like. All right. So now I can connect this to this guy. All right. Then this to the gateway. Now, if you want to introduce NAT, because let's assume we have an EC2 here. By default, since they are in the same network, this EC2 can talk to this other EC2, all right, because they are in the same network. Of course, they are going to have what? A private IP address, because from the CIDR, all right? So now, if you want an outbound traffic to the network, what happens? Then you need to do what? You need to bring in NAT. So this is what a NAT looks like, a NAT gateway. All right. So, but the NAT is going to do what? The NAT, sorry. So the NAT is going to be where? In the private subnet. Okay. So this is how communication is going to look like from this guy to this guy. Then this guy will, this is what is going to take traffic. All right. Then this NAT will, of course, the address of this NAT will be configured in the private subnet route table. You can make yours more cleaner than this. Or I can bring this guy down here. Okay. So this guy to this, it is not passing through the public subnet route table. All right. So, but you are definitely going to add it to the private subnet route table, because this is what is going to define how it's talked to the internet. All right. So you can bring in the CIDR here, because each of the subnet has their own CIDR. Okay. So come here and text. So I can bring this here. Okay. So I can duplicate this, take it to this other guy. But instead of 1, we're going to have 2. Okay. Is there any question?
Yeah. Okay. Go. You can go first.
Yeah. So just for you to throw a little more light, I mean, in the real world, we know that the NAT functionality and the gateway router, they all sit or live on the same device. So it appears that, yeah, things are quite different when it comes to cloud environment. The functionality that responsible for NAT differs from the service responsible for internet gateway functionality, right?
A little.
Because even during personal studies as well, I think I've come across the same concept as you are also carrying us along here, where NAT is the a separate icon represents the NAT functionality, and a separate icon represents internet gateway. So these two functionalities, they don't live on the same service, right?
No, they
They are
don't.
performed by different services.
Yes, different. So
Oh,
what happens is that now, if I take out this gateway, let's assume this is where my web server is, this guy here. All right. So now we understand that the web server, it's where, let's say, your website is running. And definitely, without internet gateway, these guys can actually look at what is inside here by default. But then, unless it is a web server, a website designed for a particular organization that needs to run internally, and this is fine. But if it is a public-facing website, let's say maybe something like this, your docs.google.com, then we bring in an internet gateway. All right. So internet gateway is with the help of the public IP that this guy has. All right. So it's going to help us route traffic outside the VPC. Now, while I bring in NATs, we already know that NAT is what? Network Access Translator. We all have NAT in, let's say, our routers. For instance, let me use our router, for instance. Now, our router has what? A NAT. Sometimes, if you are connected to an ISP is going to assign a public IP address to this router. Now, for devices connected to this router, the network access translator is in charge of what? Also assigning public IP addresses to each of these guys connected here. And also with the help of this NAT, this is also what enables your device to actually go out from this network and reach the internet. The same thing with your mobile device. Let's say you are using a SIM card for your data, or then, there's what we call a carrier network. Your ISP is going to give you a public IP with the help of this carrier network. So that public IP it's going to be assigned to this carrier network. Now the NAT inside the carrier network is now in charge of giving your mobile phone, that is if you are using your data straight from your phone, is now in charge of giving your mobile phone a private IP address. So this is why if anyone is connected to your router, let's say someone use your network for theft or something, it is always traced back to you, because ISP is not seeing the guy. What the ISP is seeing is you. Now let us see how AWS works. Now let us assume this web server, or this is a database, or okay, let me not use database. This is a back-end application or an API. Or yeah, let me use so that since we've not really gone to application deployment, let me use a very easy scenario, a front-end application. Let's say, for instance, the application running here needs something like a profile picture. When you upload a profile picture, instead of saving to the server, you should save to a particular data storage outside this VPC. Definitely, because this guy, the network here, it's only private. All right. Now this guy will need a NAT. And now the NAT is not supposed to be here in the private subnet with this guy. The NAT is in the public subnet because the public subnet already has an internet gateway which defines how network should leave this VPC. But then you must also define your own route table, that is your own rule, separate rule, that also defines how this NAT is also going to access this guy. I really don't know. I don't know if I've been able to explain anything.
Yeah, it makes sense.
All right, so these two guys are actually very different. I understand your points. I understand your points very well. In a conventional network, there's actually one device that does the same thing, but you have to configure them separately. But especially in AWS, we have two different devices that you can use to configure for different purpose.
All right.
Yeah, and sorry, and adding to it, I just want to know in this infrastructure illustration here, where do we need to put our firewall?
All right, so the firewall, if you are going for the NSCL is going to be on the VPC level. But if you are using security group, the security group is going to be in the subnet level. Now, although it is actually host inclined, but then if you put it here, even if you have two EC2 servers here, they are going to assume that security group. So the firewall is going to be here. Don't know
Okay.
if this guy has security group. So the security group is going to be here.
So mostly it's actually on the private side where you have the linkage to the internet gateway.
What did you say?
I said, so is you actually put the security group majorly on the public side because the private is actually secured. There's no interaction. There's no outbound interaction, right?
Well, not really. The security group can be attached to. You can define separate security groups for your subnet. You know, when you're designing any infrastructure, you should always assume that the next person is the target, or you should always assume that you yourself are the target. So when you're always designing something, make sure that it is like zero trust security. All right, because even without you bringing internet gateway, all right, your network is secured because nobody can actually access these internets. But then you should still bring in security group because anybody here in this subnet can actually sniff what is going on here, and anybody here can also sniff what is going on here. So you can bring in security groups to actually limit what protocol should be inbound and also outbound in each of the subnets.
Okay.
Please, before we move forward, is there any question? Is there any other question? All right. So this is our AWS console. All right. So this is the service you are looking for. Should in case yours is not here, just go to the search menu and search for VPC. So this guy here, isolated cloud resources, then we click on it. It's going to bring up a VPC console for us to manage. Now, if we click on your VPCs, if we click on your VPCs, all right, so you're going to see the list of VPCs you have in your account. Now, before we go to VPCs, AWS has what we call regions and availability zones. Now, not just AWS, any cloud environment has a region and availability zone. So what is a region? So a region is more like a geographical location. All right. A region is more like a geographical location. Now, availability zones are where data centers are placed in that region. So for instance, this can be a region. All right. Now, inside this region, we have different data centers, and these data centers are referred to as availability zones. So you can launch your application in one availability zone, launch the same application in another availability zone, launch another one in another availability zone. So let's assume that this data center is down, then people will still have access to your data or your website or your web application. All right. So this is what makes your application to be highly available. Okay. So now let's assume you only launch your application in one availability zone. Let's say this one. We've been hearing rumors that AWS Cloud has been down for a while. I think around January, AWS Cloud was down, and most companies were not able to access their resources again. So stuffs like that can also happen to you. All right. Now, sometimes the outage can be in a particular region. Sometimes the outage can be limited to just one availability zone. All right. So now, in terms of availability zone also helps when it comes to data governance. For instance, you are in, let me use Europe. All right. And your company is maybe asked you to design an infrastructure for running their services in, let's say, Europe. All right. Now, it is not wise for you to design an infrastructure for your company's data to live in the US. All right. So you can read on policies regarding users' data. Okay. So get your infrastructure provisioning right, because it is sometimes can be punishable by law, and you are going to pay a huge fine. Well, not you, maybe your organization. So I think it's you can read on the GDPR law, GDPR, General Data Protection Regulation. So it applies to any organization handling. This is this actually governs the I think Europe. So you can read on this. US has theirs, other location has theirs. All right, so you can read on it. But then if you take a look at this, I am using the US East one region. So these are the list of regions. All right. You can also enable some regions. There are over 17 regions that are not enabled for these accounts. All right. So you can click on the managed region and enable some regions for yourself. So this is US East 1. Then US East 1 has different data centers, 1A, 1B, 1C, I think up to 1F. Ohio is US East 2. North California, US West 1. Oregon West 2. Then for this Asia Pacific regions, Mumbai, Osaka, Seoul, Singapore, and the rest. So always choose the region you want to use based on what you are provisioning for. All right. And this region also helps when it comes to things like latency. Okay. For instance, your users are in the US, but you are provisioning provisioning a server in Europe. All right. So there's going to be a little bit of latency. Not like it is going to go through, but the time to leave, it's going to be you're going to have, I think, late latency, something like that. So you can also read on regions. All right. So back to our VPC. So we create on this are the VPCs I have. So if you come to VPC section, you're going to have a default VPC. So yours may not have a name. I actually renamed mine. All right. So I renamed mine to default. So what yours will have is just the VPC ID. So if you see a VPC ID without a name, then that is your default VPC. All right. So you can rename it if you want. So what I would do is we are going to create a VPC. Click on create. Now there are two options to create a VPC. VPC only and VPC and more. So if we click on VPC and more, so we actually going to stay here and provision all our resources. But we want to see what we are provisioning. So I'm going to click on VPC only. Now the first thing that comes up is the name of the VPC. Now I love a very clear name, all right, because it helps to identify things easily. Now we are working with what? Charity organization. So I can just say, okay, my VPC name should be charity. I can say charity VPC. Okay. Now the next thing is what? You can leave this. No, you should leave this at the IP version 4 CIDR manual input. All right. So because you'll be the one to input a CIDR yourself. All right. Now, if you notice, you are asked to do what? Input the CIDR. Now, what was I CIDR? CIDR is 10.0.0.0/16. So I'll copy this, go back to our VPC and paste it here. All right. Now for the tenancy, we are leaving it in default. Now, we have two types of tenancy in AWS. We have the default tenancy and we also have the dedicated tenancy. This applies to any resource you want to create in AWS. Now, default means that you are using a shared infrastructure. For instance, if we are creating a route table, it's going to be shared. If we are creating a VPC, the resources that AWS will use to create the network for you are shared. Now, if you need a dedicated one, maybe just for yourself, the difference is that you are going to pay more. All right. If I'm paying $0.1 for default, then you can pay $5 because it is just for you and yourself. So since this is demo, I'm going with default. All right. So for the encryption mode, we'll leave that none. All right. So I think we are good. So we'll create our VPC. Now, if we come to VPC, we can see that our VPC has been created. All right. So this is our VPC, charity VPC. Now, this is just a network. Now, the next thing we'll do is what? We'll create a subnet. So creating a subnet, I'm going to click on subnet and I'm going to click on create subnet. Now on the subnet tab, I'm going to do what? Select the VPC I'm working on. So I'm working on what? Charity VPC. All right. Now it's automatically going to bring out the CIDR for you. Now for the subnet name, I'll create the first subnet. I can name it public charity. Okay. Now this is where you choose the availability zone for your subnet. Now, if you don't choose anyone, if you see, we have how many availability zone for US East 1, 1A, 1B, 1C, 1D, up to 1F. Now, if you don't choose anything, AWS is going to do what? Choose one for you. All right. So you can leave it or AWS can choose one for you. Now, this is what? Your VPC CIDR block. Now, this is where you define your own subnet CIDR block. For the public subnet, what do we have? 10.0.1 or .1.0/24. So we impute it here. Okay, so it automatically tells you that, okay, it is only 256 IPs that is allocated to this guy. Now, in AWS always reserves 5 IPs for itself. 256 minus 5. All right. So what is usable for your host is always 251. Some people do ask this in interview concerning VPCs. So how many IPs does AWS reserve? So it's always 5. All right. So that means out of these 256, you can only use 251. So that means you can only create up to 251 EC2 instance in this subnet. Okay. So create a subnet, we'll review. Okay. Then we create. So this is for one subnet.
Please, can I just
So
ask a quick question? A quick
all
one.
right, okay. Okay.
Yeah, just for those who may eventually want to take an exam on this, the 256 available IPs in AWS, does it not also take into consideration our usual network and broadcast addresses?
It does. It does. That is where the 5 is going to.
Okay.
So one is used for broadcast, one is used for your gateway. Let me try to get the others, but that is where the rest is going to. So hold on, let me find that out. But one is used for broadcast, one is used for gateway, one is used for AWS itself.
Okay.
Let me get that. Let me get that.
I thought the 5 were for a different kind of reason.
No, it's used for that purpose.
All right.
All right, so one is used for the network address, one is used for the gateway IP, one is used for the DNS server IP, one is used for AWS itself. It's always regarded as future use. Now, the last one is for the broadcast address.
All right.
So,
Makes sense.
yeah. So we have public subnet. So let us create another subnet. So we're still in the charity VPC. And all right, so I'll call this charity public. Okay. Now and again, if you don't choose an availability zone, AWS is going to choose one for you. So paste this here again, 256. The same thing with public. So the usable IP is 251. AWS takes the rest for your broadcast, network, gateway, DNS, and the rest. All right. Now our VPC is ready. What have we achieved? We've achieved the VPC itself. We've achieved the subnets. All right. Now AWS, when you create a VPC, AWS automatically do what? Create a route table for you. Now let us go to what? Route tables. Again, what is our VPC ID? These are our VPC ID. VPC is 0DD04. So we come to the route table. All right. So automatically AWS creates what? A route table for us. Think this should be it. Let me open this. No, this is not it. Well, but when you create a VPC, AWS is definitely going to create a route table for you by default. But then, since we've not seen us, we should go ahead and create a route table for ourselves. So this is our VPC ID, VPC 0DD. Let's confirm first.
Or try refreshing.
Okay. But all right, thank you. So this is it. All right. So AWS creates a default route table for us. Now with this route table, the two subnets can communicate with each other. So if you open up the route table, we see what this is our VPC CIDR range. Our target is what? Local. Local means it is just for what? The VPC. That's for resources inside the VPC. All right. It is local. And active, propagated, no. All right. So this is it. But then we are going to create our own custom route table. Now, the main essence of us creating our own custom route table is for us to do what? Define a separate rules. So because let's assume that I have just one route table. Remember that route table does what? Route table defines the path that traffic should go. I have one route table, and inside the route table, I attach a gateway. And in that route table, the private subnet and the public subnet is attached to that route table. Now, because I have attached a gateway to that route table, this automatically makes the private subnet public as well. I don't know if that makes sense.
No, I just wish you can just repeat the few points you made the last 1 minute.
All right. So, like I said, or like we have seen, AWS has created a route table for us. So this is really, really fine. All right. Because this route table is what makes communication between the two subnets we've created, all right, to talk to each other, just like these two guys here. So that means this EC2 here can talk to this other EC2 here. But then remember that we are doing what? We are going to create an EC2 inside each of those subnets. Imagine we create an EC2. We use that EC2 to host a web application. Hosting a web application simply means what? We are going to bring in a gateway, internet gateway, to help us define rules of how the VPC is going to access the internet, and also how people outside the VPC can also access resources inside the VPC. Now, if I attach the gateway, all right, to that route table, now let's see what happens with this. Let's assume I have just one gateway, and let me attach this guy to this other route table, and the gateway is also attached here. I hope you know that people outside the internet can also view what is inside here because of this gateway. Is that clear?
Oh, really? Okay.
Is that clear?
Yep.
All right. So because of that, we are going to do what? Create our own custom route table for ourselves. So this is how it is. We go to route table. All right. Go to route table. We'll create a route table. So I can call this, this route table is going to be for the public subnet. I can call this charity public route table. All right. Now I'm going to attach this to a VPC, charity VPC. Okay. Then create this route table. Now, creating this route table is not enough. What do? We come to subnet associations, and we are going to associate the subnet. So if I click here, this is for public. Hold on. We use the same identity for two subnets. Okay. So please remind me. I'll need to change this. So I'm going to associate.
Please, I just wish we can modify the name so we have better clarity and follow along this.
All right. So let me do that. Let's go to subnets. Public charity. So I can name this private charity. All right, so I've come to route table, and okay, we already have a route table. So this is for the public route table. So I'm going to edit this, click on subnet association. All right, so edit association. So what we are basically doing is we are modifying the route for the public subnet. All right, so I'll click on this first guy. If you notice, I have not associated a private subnet too. If I associate a private subnet, it simply means that it's automatically going to be public because I am going to attach internet gateway to this guy. So I'll save. All right. So we have modified our route for what? Our public subnet. Now we can now create what? An internet gateway. So this is our internet gateway. We create an internet gateway. We can call this charity IGW for internet gateway. All right. So I'll create the gateway. Now, creating the gateway is not enough. If you notice, we did not select the VPC when we're creating the gateway. So what I'll do is I'll click on actions, attach to a VPC. I'll click on attach to a VPC, then we select the VPC we are to attach to. Click on charity and attach. Now this gateway is not attached to a VPC, to our VPC, but the route is still incomplete. All right. So we need to go to what? The route table we created, which is the charity public route table. All right. And also define a route. Also define a route, or sorry, not define. Also add the internet gateway route to this public subnet. All right. So that now what we have just done is just to attach the route table to the VPC like this. Now, even when we've attached the VPC does not actually know how this internet gateway should communicate to this guy. All right, because we want to attach this route table to the public subnet. So we need to also define the route here. You know, the only route we have here is what? For the local VPC. That is the two subnets to talk to each other. All the resources in this VPC to talk to each other. So I'll click on edit route. Now, if I click on edit route, so this is me adding the route to this guy. All right. So what I'll do is I'll click on add route. Now I'm going to use a wildcard because what this wildcard simply means is that everybody on the internet should be able to access these websites. So this is the wildcard. So all the IP addresses in this world is inside this wildcard. 0.0.0.0/0. All the IP addresses in this world is inside here. So what should be our target? The gateway we created. And we select the gateway, which is the charity gateway, and we save changes. After saving changes, how many routes do we have? 2 routes. The first one is what? For gateway. So that means any communication coming into here, into the VPC, is going to pass through what? The internet gateway to the route table. Then the route table decides where it should go. Now, if this guy wants to talk to this guy, then he's going to still use this route table. So from here to the route table, from the route table to this. So this is what is here. So we have a route table. Okay. So now this is done for this part. Now, if you want, you can also go ahead to create a route table for this guy. Okay. So we bring up a route table for this guy. Now, because we have a NAT gateway in the public subnet, all right? So the NAT gateway is going to use this guy for communication. Actually, the arrow is wrong. The arrow should be outbound, not inbound. So take notes. So if this guy wants to access any resources outside the VPC, it goes to its own route table, then the route table to the NAT gateway, then the NAT gateway. Since the NAT gateway is in a public subnet, the public subnet already has a route table. So it follows the NAT gateway route table, then to the internet gateway and out. But nothing comes in to this guy because NAT is only used for outbound. So let us implement that. So we also create a different route table, all right, for our private subnet. So I'll call this charity private route table. Okay. So I'll select a VPC, which is still charity, and I create. So the next thing will be for us to do what? Subnet association. Which subnet are we associating? Just the private subnet. And I associate it. Now let us go ahead and create what? Our routes. Sorry, our NAT gateway. So we create the NAT gateway. This is the NAT gateway. We create the NAT gateway. Click on this guy. Create a NAT gateway. So we can call it for charity private, or can just call it charity NAT. All right. Now there are two availability mode for gateway. Although we only had the zonal availability mode, so the regional is quite new. But for regional is going to scale through each availability zones. All right. But this is only okay for the charity. So we can select charity. Okay. Now, if you choose zonal, okay, although zonal is the recommended approach. All right. Now, if you choose zonal, remember that your NAT gateway should be where? Your public subnet. So we are going to, so zonal is only tied to a specific availability zone. So that means you need to create different NATs. Let's say if you have public subnet in 4 availability zones, then you need to create up to 4 NATs. All right. So it's as easy as that. But so I will choose zonal. Then we are going to select the subnet we want to attach it to. And note, put it in where? Public charity. So I'll click public. All right.
Sorry, Samuel. Just sorry to cut you short.
Okay.
What you just said now, please, can you just repeat it? I'm just trying to get it. You said
Which?
concerning the zonal and the regional, please.
Okay. All right. I'm trying to look for a way to make this easier, but just a minute. All right. So on the availability mode. Now, this is where we get to choose whether to deploy our NAT in all zones. Remember, we have how many zones? 6. A, B, C, D, E, F. We have 6 availability zones. All right. But how many availability zone do we create for our public subnet? Just one. Can you recall?
Yeah, that's in the US, not Virginia.
Yes, but that's the zone. But AWS gave us, since we did not actually choose a preferred availability zone, it gave us I think, was it A or B? But we'll go back to that. But then we have two availability mode. We have the regional availability zone, and we also have the zonal. Now, if you choose zonal is restricted to one availability zone. So that means if you have 4 subnets, let's say 4 private subnets or 4 public subnets, all right, in different availability zones, you're definitely going to create 4 NATs. Now, this guy is actually a very new concept, although I have not experimented with this yet. But what this guy means is that it's going to scale automatically for you. You don't need to manage it like the zonal, the zonal availability mode. And remember that we need to create our NAT in where? Public subnet. Okay, so now you choose a particular subnet per availability zone. If you are choosing zonal, all right, which is what we did here, we have just one subnet, which is a public charity. And let's check. This is the availability zone. Can we see US East 1D? Can we all see? This is what AWS gave us. So this NAT we are creating is only going to be tied to US East 1D. So just know that, and it is not just limited to NAT. In AWS, if you create a zonal resource simply means that it's going to live in one availability zone. All right. So a regional resource spans through the entire region. And also, while I am also choosing zonal, is because I really don't want AWS to charge me much, because AWS is going to scale this automatically for us. All right. For instance, if I choose this regional, then I'm going to select what's a VPC, and this is my VPC. All right. So then I'm going to choose the connectivity type. Of course, it's public because we are going outside a VPC. All right. But for this demo, I'm going with the zonal availability mode. You can also experiment, although it's just the same thing, but this spans across all the availability zones you have. And for me, it's really not practical because we created just one availability zone. So let us limit it to just zonal. So we'll look for the public subnet we created, which is this guy. All right. Then we'll keep it at public. All right. Now, if we come to this diagram, without a public IP, this NAT cannot access the internet. So we must allocate a public IP for this NAT. I don't know if that makes sense. Are we still here?
Yeah.
I'm here.
Okay. So your NAT needs a public IP. All right. So that instances in the private IP. So the public IP, which will be given to NAT, is what is going to be assumed by the instances in the private subnet when they are communicating with the outside world. So any outbound traffic leaving this subnet is going to do what? Assume this public IP. So we'll need a public IP. Please, when you're experimenting on this, delete your public IP. Delete your VPC and delete your IP, because public IP is actually very expensive, especially in AWS. So we click on allocate a public IP. So AWS is going to allocate one for us. All right. So this is our public IP, 3.222.214.93. All right. So this is what the private subnet is going to assume. All right. Then we click on create. So after clicking on create, it's going to be in the pending states. It can take like 4 minutes, 5 minutes for it to be available. But the last thing we are going to do, we will go to our private subnet. Private subnet. This guy here. Sorry, not private subnet. The private internet gateway. Sorry, private route table rather. And also add the NAT gateway route, because the NAT gateway is what is going to use this route. All right, so we add the entry there. So we click on edit route, add. All right, so what are we adding? Since it is visiting the outside wall, we use this guy. Then our target is NAT gateway, and which gateway? Charity NAT, and save changes. So our VPC is now complete. So we are now left with what? Security group. So for the security group, what do? We create a security group for our VPC. So I'm just going to create one for the public subnet. So I'll come here, create a security group. Under security, all right, then you create security groups. So I can call this, I'm going to call this charity SG, security group. So description for my VPC. Okay. Then for the VPC, we are going to select the VPC this should be associated to, of course, charity VPC. All right. Now remember that security group has what is tied to a particular subnet or is tied to a particular host. All right. Then we have the inbound rules and the outbound rules. So the first rule is what? Public access only on HTTP. Public access on HTTPS. All right. So we come to the security group. We'll add a custom rule. So we click on this custom. Then you can search for HTTP. HTTP is here. It's going to automatically associate the port with it. Then for the source, we are asked to allow public access. So public access means anywhere on the internet. All right. So I'm going to click on this guy, anywhere. We add another rule, HTTPS. We look for HTTPS. 443, anywhere. Add another rule. Another rule is what? SSH. But the rule on SSH says that we should only allow administrative access only. That means limited to just me. All right. So what I'll do is, instead of anywhere, I'm going to select my IP. So this guy is I'm going to give me my IP. All right. So this is my IP address on the network I'm connected to. I switched network actually. So this is my IP address. All right. So I think our security group is, you don't necessarily need to configure the outbound rule. Okay. Like I said, it is what? Stateless. Or stateful rather. So we can go ahead and create security group. So our VPC is fully ready. Okay. So we have our NAT. We are only left with to create an instance. So let's see what happens. Let's see if our NAT is ready. Although we are not going to work with NAT today, but our NAT is ready. Okay. So we are only going to work with a public subnet. So let us go ahead and create an EC2 instance. Please, before we do that, is there any question?
Yeah, concerning the direction of that rule, So I don't know for others. I understand what the concept of stateful and stateless, but that direction, you were a little bit fast there. Is that outbound?
For which place?
Inbound? The security group you created. What direction is that?
Inbound. Sorry. Inbound. We are creating inbound. Inbound traffic. What is coming to the server?
Okay. Okay.
What is coming to the server? So this is it. Where's the security group we just created? Thought we created a security group just now.
Can you search by a keyword?
Okay, see it's here. All right, so this is it.
The name didn't apply or what?
They did. It did. So this is it, just inbound rules.
Okay, okay.
Yeah. So this is the outbound rule. So outbound rule is for all traffic. So,
Okay.
but the security is always on the inbound.
Inbound. All right, thank you.
So let's go ahead and launch an EC2 instance. I'll search for EC2. So what I'll do is I'm going to launch an instance. Okay. All right, so I'll give it a name. I can give it server if I want. Server. Or let us follow our naming convention. Charity server. I'm going to use an Ubuntu image. Now the next thing I'll do, the instance type here is very okay for me. All right, so I'm going to pass that. Then I'll choose my security key. You can create yours. I already have this guy, server. So you can use the old one you have, or you can create a new one. Now, this is where everything gets interesting. On the networking tab, what do? We usually use the default, but instead of default, we use the one we created. So I'll click on edit. All right. Now, we're editing the networking now. So we'll select the VPC. All right. Charity VPC. Now, the next thing is what? For us to select the subnets. Okay. So click on charity public subnets. If you notice, we have two subnets here, private and public. But since we are hosting a website, I'm going to choose the public subnet. So we have what? Just 250 IPs available for this subnet. Now for device or for resources in the public subnet, we need to do what? Enable public IP so that our EC2 instance is going to get what? A public IP for us to be able to interact with it. But for devices in the private subnet, you don't need to enable this guy. All right? It should be disabled. Now for our security group, we'll select the security group we created. All right. So charity SG. So I'll go with this. So, and that is it. Click on launch instance. So give it a minute for our instance to come up. Then what is left? So let us go to our instance. So we have launched an EC2 instance in this VPC. So we are left to do what? To deploy this website. So what I'll do is, this is our instance, charity instance, this guy here. Okay. Let me refresh this. So it's still in the initializing stage, but it's actually up and running. So this is our public IP. So can we see from our private subnet, had what? Sorry, our public subnet had what? 10.0.0. Sorry, 10.0.1.0. So it's giving us an IP from our private subnet, which is 10.0.1.189. So it's going to choose anything for you. So this is for private, but this is what we use over the internet. So I'll copy this. Then we'll do what? Let us connect to our instance. All right. So my key is in downloads. So I'll do SSH -I, then I'm server, then Ubuntu, the IP address. So hit enter. Yes. Now I'm able to log into this guy because now if I should give you this private key and give you the IP address of this server, you'll not be able to log into this server, even if you have the correct details, because it is only limited in my security group, on the server security group, it's only limited to my what? IP address. If that IP address should change, I'll need to go back to that security group and change the IP address to what my local system IP address is. If not, I'll still be locked out. So the first thing is what? Sudo apt updates. All right, so it's going to update our packages. Now we want to do what? Run a web server. All right, so what do we use to run a web server? Nginx. So we are going to install what? Nginx. You can use Apache. All right, there are so many applications or tools you can use to run a web server. You can use Apache. Okay, but Nginx is very popular. Nginx is widely used in production today because it can handle millions of connections. It is robust. All right, so it's actually very popular. So we are going to use Nginx. So what do we do? Sudo apt install Nginx. Now I'm going to add -y because I don't want this guy to keep asking me if I want to install Nginx. So I'll hit what? Enter. So it's going to install Nginx on the server for me. All right. So how do I know my Nginx is running? Sudo system ctl status Nginx. If I hit enter, Nginx is what? Up and running. So how do I confirm that Nginx is up and running? So what I'm going to do is I'm going to copy this public IP, go to the internet, all right, and test it. So this guy should output the default Nginx page for me, which should tell me that, okay, Nginx is up and running. So our server is now a web server. All right. So now in Nginx, there's a default web root. Where is this guy? In Nginx, there's a default web root called /var/www/html. All right. So this is the directory you should host your application. Okay. This directory is where you should host your application. Now, let us see what's going on. If I go to cd/var/www, all right, /html. If I do ls, so this is the default web page that is loading up. So if I cat, now I cannot just use cat here. I need to use sudo because this is what the root directory. So sudo cat. Can we see? Welcome to Nginx. Welcome to Nginx. If you see this page, the Nginx web server is successfully installed. If you see this page, the Nginx web server is successfully installed. Now, let us go back to our home directory. If you don't configure your security group right, you may not be able to access that Nginx. So now, the next thing I'm going to do, this is the website we are working with, all right? So the next thing I'm going to do is to clone this website. Now, we are going to, when we start talking about version control and remote repositories, we are going to look at this in detail, but for now, you can just use the command I'm going to use. So I'm going to clone that repo into my server. So because that website is in a remote repository, in a Git remote repository. So to clone it, I'll use the command git clone. So you can also use this command, git clone, all right? When we do versioning, we are going to talk about what Git does. So git clone, then I'll simply paste the repo link. So I'm going to have the copy of that application. So if I do ls, this is the website, all right? So I'll do cd into what charity. So I'll hit enter. So remember that the website is what? It's just a folder, bunch of files inside a folder. So we are now inside that folder. So what we are going to do is we are going to copy everything here to /var/www/html. So I hope we still remember our copy command. But since we are copying from the home directory to the root directory, we need to do what? Use sudo. Sudo, the copy command is what? cp, if you have been practicing. Now, I'm going to use -r. Why am I using -r? Because there are different bunch of files here. I also have a folder here. If I do only cp, it is only going to copy the files, but I want to copy everything with folders, pictures, if there are videos, inclusive. So I use -r, all right? Now, I'm going to copy everything because I don't want to do sudo cp 404.html. I don't want to copy them one after the other. I want to copy everything in this folder. So I'll use this command. So this command simply means that, okay, I am inside here. So copy everything. This asterisk means everything inside this folder. Everything inside this folder. So what is our destination? /var/what www/what html. All right, so I'll hit enter. Now let us go to /var/www/what html and do ls. Can we see everything is down here? Everything is down here. So what do? We restart Nginx. Sudo system ctl. Instead of status, we use restart. We are simply restarting the Nginx server so that it can now have these changes. Restart Nginx. So we hit enter. We go back to this guy and refresh. If you refresh, we should see the content of our website here. Let's give it a moment. So if you also want to try loading up this website, I've dropped the website on the chat. So you can also try these sites out, then to see how it is loading up. So this is the website we have hosted on our EC2 server. So this is how websites are actually hosted. I don't know if you have any question. Are we still here?
Yes.
So I want to believe it is clear so far.
Yeah, it is.
Yeah.
All right. So has anyone tried to load up the sites? Is it coming up from your end?
Yes.
All right. So so this is just how so we've provisioned a VPC, a custom VPC, and we've launched a an EC2 instance in that VPC, then use it to host a website. All right, if there are no questions, then we can stop the class here. Then we'll continue next week. All right, so I'm going to share this exact documentation for us, so you can also try things out. All right, then you can also try maybe hosting a server in the private subnets. All right, then see how requests are made outside the VPC. Okay, so if you have any questions, you can drop it on the group, then we'll see it together. So I'll drop this stuff, then when the video is ready, then I'll let us know. All right, thank you. I'll stop the recording now.
Thank you. Thank you.
Thank you.
All right.